Let me ask you something strange. Why aren't you exploding right now? No, seriously, your body is filled with warm liquid water. Your lungs are full of gas. Your blood carries dissolved oxygen. If you were suddenly placed in empty space, you wouldn't just suffocate. You would start to boil at room temperature. So here's the mystery. Why doesn't that happen here? The answer is invisible. It's heavy, and it's sitting on your shoulders right now. Atmospheric pressure, and without it you do not exist. Let us slow down for a moment. Stand still. Take one quiet breath. Now ask yourself something simple. What is above your head? You might say, clouds. Maybe the sun. But physically, truly, physically, what is above you is a column of air stretching all the way from the ground to the edge of space. And that column has weight. We are used to thinking of air as nothing. You cannot see it. You can barely feel it. But air is made of molecules. Nitrogen, oxygen, argon. Tiny particles moving at incredible speeds. Each one has mass. And when you gather trillions upon trillions of them together under gravity, they press downward. Gravity does not stop at mountains. It does not stop at airplanes. It pulls on every molecule of air above you. Imagine stacking invisible layers of air one on top of another all the way up for hundreds of kilometers. That entire stack is pressing down on you right now. The force? Roughly 101,325 pascals. We call it 1 atmosphere. In simpler language, about 10 tons pressing on every square meter of Earth's surface. 10 tons. That is the weight of a truck. And yet, you are not crushed. Why? Because physics demands balance. Inside your body, your blood, your lungs, your cells, everything contains pressure too. The fluids inside you push outward with equal strength. The molecules inside you collide with your skin from the inside, just as air molecules collide from the outside. It is a perfect equilibrium. You are not being spared from pressure. You are being matched by it. This is the quiet miracle. Life exists not because pressure is absent, but because pressure is balanced. Now imagine removing that balance. Imagine in an instant the air disappears. No gradual fading. Just gone. The outward pressure inside your body would no longer have anything pushing back. The liquid water in your tissues would begin to boil not because it is hot, but because the surrounding pressure vanished. Boiling is not about heat alone. It is about pressure. And here on Earth, atmospheric pressure holds water in its liquid state at temperatures where life can function. It holds your blood together. It stabilizes every droplet inside you. You live at the bottom of an invisible ocean of air. And like fish deep in the sea, you are perfectly adapted to its weight. If a fish suddenly rises too quickly, the change in pressure harms it. If you were suddenly lifted into space, the same principle applies. The lesson is simple and profound. Air is not empty. It is structure. It is force. It is support. Every second of your existence is a negotiation between gravity pulling air downward and molecular motion pushing outward. And in that silent balance, in that steady, invisible pressure, life finds its stability. We do not exist despite the weight of the air. We exist because of it. Now let us go deeper. We say water boils at 100 degrees Celsius. But that is not a universal law. It is a local agreement. Boiling is not about reaching a magical temperature. Boiling happens when a liquid's internal vapor pressure becomes strong enough to push against the pressure surrounding it. In other words, water boils when it can finally escape. Inside liquid water, molecules are constantly moving. Some move slowly. The fastest ones try to break free into vapor. But at Earth's surface, the atmosphere presses down with steady force. That pressure holds the water together. It says, not yet. Only when the water is heated enough that its vapor pressure matches the surrounding air pressure does it begin to boil violently, forming bubbles throughout the liquid. Now imagine climbing a high mountain. As you rise, the air becomes thinner. There is less weight of air above you. The surrounding pressure decreases. Suddenly, water no longer needs to reach 100 degrees to escape. It can boil at 90 degrees. or 80. On very high peaks like Mount Everest, water boils so early that cooking becomes difficult. Food takes longer because the water cannot get as hot. The temperature didn't change because water decided to. It changed because pressure changed. Now take the thought experiment further. Imagine removing the atmosphere entirely. No air, no pressure. In a vacuum, water does not politely wait until 100 degrees. At room temperature, even at body temperature, its molecules are energetic enough to break free. Without pressure pushing back, the liquid begins to boil immediately. Not because it is hot, because nothing is holding it together. This is the crucial point. Liquid water exists on Earth because the atmosphere presses on it. Without atmospheric pressure, the oceans would not rest quietly in their basins. They would rapidly evaporate, molecule by molecule, drifting into space. Look at Mars. Its atmosphere is extremely thin, less than 1% of Earth's. Liquid water cannot remain stable there for long. It either freezes or sublimates into vapor. Now look at Venus. There, the atmosphere is so thick and heavy that pressure is crushing. Temperatures soar, and water long ago vanished in a runaway greenhouse effect. Earth sits in a delicate middle. Our atmospheric pressure is strong enough to keep water liquid, yet gentle enough to allow life to breathe. And liquid water is not just convenient, it is essential. Chemistry inside cells requires molecules to dissolve, collide, rearrange. DNA folds in water. Proteins move in water. Blood flows because water remains liquid. If water boiled away at room temperature, life would not slowly struggle. It would never begin. So when you look at a calm lake or hold a glass of water, remember this quiet truth. It is not just gravity that keeps it there. It is the invisible weight of the sky. Atmospheric pressure is the silent guardian of liquid water. And liquid water is the stage upon which every living story is written. No pressure, no oceans, no chemistry, no life. The reason water does not boil right now is the reason you are here. Now let us bring this down from oceans and planets to something intimate. Your next breath. We often say, I suck air into my lungs, but that is not what happens. You do not pull air in like drinking through a straw. You change pressure. That's all. When you inhale, a thin dome-shaped muscle beneath your lungs, the diaphragm moves downward. Your rib cage expands slightly. The volume inside your chest increases. And when volume increases, pressure decreases. This is one of the simplest and most beautiful rules in physics. When space gets larger, pressure drops. The air inside your lungs becomes slightly lower in pressure than the air outside your body. And air, obedient to physics, moves from high pressure to low pressure. It rushes in not because you dragged it in, but because the atmosphere pushes it in. Breathing works because the sky presses on you. Pause and feel that. Every breath is a partnership between your muscles and the weight of the air above you. Now consider what happens if that pressure changes. On Earth, the atmosphere provides a steady external force, about 1 atmosphere of pressure pressing on your chest, your skin, your lungs. But imagine standing on Mars. There, the atmospheric pressure is less than 1% of Earth's. Even if you had oxygen available, your lungs would struggle. The pressure difference required for normal gas exchange would collapse. Oxygen would not dissolve into your blood efficiently. Breathing is not just about oxygen existing. It is about pressure gradients allowing oxygen to move. Inside your lungs are millions of tiny air sacs called alveoli. Oxygen moves from these sacs into your bloodstream because of differences in partial pressure, a subtle imbalance that drives diffusion. Your body depends on these microscopic pressure negotiations. No gradient, no flow, no life. Even exhaling is a pressure story. When your diaphragm relaxes, the volume in your chest decreases. Pressure rises slightly. Air is pushed out. Inhale, lower pressure inside. Exhale, higher pressure inside. A rhythm of expansion and compression. A quiet conversation between your body and the atmosphere. You are not separate from the air. You are mechanically linked to it. If atmospheric pressure vanished, your lungs would not inflate properly. Air would not move the way it does now. The chemistry of your blood would destabilize. Breathing is not an isolated action. It is a dance with the invisible ocean of air surrounding you. Every second of your life, you are adjusting internal pressure to cooperate with external pressure. You are not merely living in the atmosphere. You are participating in it. And the next time you inhale, notice something subtle. You didn't force the universe to give you air. You created a small imbalance, and the universe responded. Now we step back, far back, away from lungs, away from oceans, away from mountains. And we ask a larger question. Why is Earth's pressure just right? Not too weak, not too crushing, but balanced in a narrow range where life can breathe, water can flow, and chemistry can organize itself into cells. This is not poetry. It is physics walking a tightrope. Consider Mars. Mars once had rivers. It once had lakes. The surface still carries the scars of flowing water. But its gravity is weaker. Over billions of years, much of its atmosphere escaped into space. With less atmospheric weight pressing down, liquid water cannot remain stable for long. It either freezes in the cold or evaporates quickly into thin air. Low pressure means fragile water. Fragile water means fragile chemistry. Now look at the other extreme, Venus. Venus is nearly Earth's twin in size. Similar gravity, similar bulk, but its atmosphere is thick, overwhelmingly thick. The surface pressure is more than 90 times that of Earth. Imagine standing nearly a kilometer under the ocean. That is the crushing force Venus lives under. And with that thick blanket of carbon dioxide comes intense greenhouse heating. Temperatures soar high enough to melt lead. Whatever water once existed, there was driven away long ago. Too little pressure and the planet dries out. Too much pressure and the planet cooks. Earth rests in between. Our gravity is strong enough to hold on to a substantial atmosphere. Not perfect, but sufficient. Our magnetic field shields that atmosphere from being stripped away by solar wind. Our geology recycles carbon through volcanoes, oceans, and rock in a slow planetary breathing cycle. For billions of years, these systems have interacted, adjusting, correcting, stabilizing. The result is not perfection, it is balance. Atmospheric pressure on Earth sits near 1 atmosphere, enough to keep water liquid across wide temperature ranges, enough to allow clouds to form, rain to fall, rivers to carve continents, enough to moderate temperature swings between day and night, enough to support complex oxygen-breathing life. If Earth was slightly smaller, the air might have drifted away. If slightly larger, the atmosphere could have thickened and overheated. The window is not infinitely wide, it is specific. And physics does not negotiate. Gravity sets the rules. Molecular motion sets the pressure. Radiation sets the energy balance. The reason our sky presses gently instead of violently, the reason oceans rest instead of boil, the reason lungs inflate instead of collapse, is because Earth's pressure sits in a narrow, life-permitting range, not magic. Not luck in a mystical sense, but a consequence of mass, distance, chemistry, and time. Physics is precise, and in that precision, a delicate equilibrium emerged. We live inside that equilibrium, balanced between evaporation and suffocation, balanced between freeze and fire, balanced under the quiet, steady weight of a sky that is neither too thin nor too heavy, a Goldilocks pressure. And inside that narrow band of possibility, life began to speak. Now we arrive at something even deeper. Pressure does not merely allow life to survive, it shapes what life becomes. Evolution is not random decoration on a stable world. It is adaptation to physical rules, and pressure is one of those rules. From the very first cells in ancient oceans, life has depended on gradients, differences, small imbalances that create movement. Inside a cell, molecules move because of pressure differences. Ions flow across membranes because one side pushes harder than the other. Energy itself is harvested from controlled imbalances. Life feeds on gradients. Take oxygen. Oxygen dissolves into your blood not because your body commands it to, but because of partial pressure differences. In your lungs, oxygen pressure is slightly higher than in your bloodstream, so it moves inward. In your tissues, oxygen pressure is lower still, so it moves again, flowing down the gradient like water down a hill. Remove atmospheric pressure, and those gradients collapse. No gradient, no flow. No flow, no metabolism. Even sound, the vibration of your voice, is a pressure story. Sound travels as waves of compression and rarefaction through air. Without atmospheric pressure, there is silence. Weather, too, is driven by pressure imbalance. High pressure pushes outward. Low pressure draws inward. Wind is nothing more than air rushing to equalize differences. Storms are arguments between regions of unequal pressure. Hurricanes are vast, rotating negotiations of imbalance. The climate system itself is a dance of shifting pressure zones, and climate shapes ecosystems. Ecosystems shape competition. Competition shapes evolution. Pressure does not just hold oceans in place, it sculpts forests, migrations, respiratory systems, even body size. Imagine Earth without an atmosphere. No wind, no rain, no sound. No oxygen gradients. No protective shield from radiation. The oceans would evaporate or freeze. The surface would swing wildly between extremes of heat and cold. Complex chemistry would fail. Earth would not slowly decline into lifelessness. It would immediately become sterile rock. The profound truth is this: evolution is not simply the story of genes. It is the story of matter responding to physical constraints. Gravity sets weight. Temperature sets energy. Pressure sets stability. Change the pressure and the entire biological script rewrites itself. Deep under the ocean, where pressure is immense, strange life forms evolve differently, built to withstand crushing force. High in the mountains, where pressure is lower, organisms adapt with greater lung capacity and altered blood chemistry. Life bends to pressure. It always has. We often think of evolution as driven by predators and food supply, but beneath those visible struggles lies something quieter. Physics, atmospheric pressure, is the silent architect behind respiration, weather, climate stability, and chemical possibility. It is the invisible boundary condition that defines what life can and cannot be. Remove it, and evolution has nothing to work with. No water, no gradients, no sustained chemistry, just rock beneath a black sky. So when we speak of atmospheric pressure, we are not speaking of weather reports. We are speaking of the invisible foundation of biology itself. Without pressure, there is no story of life to tell.